Let's start. 9 o'clock. Well, dear colleagues, I'm glad to welcome to our workshop. And I want to invite Sergei Semeryakov for opening speech. Please.
Thank you, Andrei Mykolaievich. No, due to one of the conspiracy theory, we lived the last pandemic year. We will live in the pandemic century and even in the millennium of the sadness and illness. The sadness is the main theme of this year. We set for real communication. As you will see, Andrei Mykolaievich at the empty room when I would like to meet all of us and many others, participants of other workshop, conference participants et al. But as is, we have a pandemic condition and even conference chair directly follow the quarantine restriction to our papers. Every second papers selected by Andrei Mykolaievich and me was cut by program chairs. So today we will have only 9 talks. I wish you to produce an excellent talk, a good discussion, even in such times. So we can communicate at this workshop in any language, any English language, any Russian, any Ukrainian, or else. But please indicate a time when to our workshop to be connected any English language participants. I see or not see now Mohammed Demirbilek. I ask you to prefer use the English. Отже, мы можем продолжать на любом языке, как, собственно, и было сказано, используя все многообразие для того, чтобы получить наилучший результат. Андрей Николаевич, ваше ведение программы.
Well, thank you. Some organizing moment. Please, if you don't speak, ask a question and other, turn off your microphones. During your presentation, we can share your screen, your presentation, and change your slide. Если нужна вам будет помощь, вы можете показывать свою презентацию, менять слайды самостоятельно, но если нужна будет помощь наша, здесь есть вот коллега со мной, который управляет презентацией, мы выведем на экран со своей стороны и будем помогать сменять слайды. Ну что ж, for first report, first speaker, I welcome Alexander Kolgatin. Please, Alexander. Связи. Your report on topic computational modeling of stochastic processes for learning research. Please. Александр, вас не слышно.
Включите микрофон. У вас он выключен.
Я уже просто предвкушению. Вам свет выключить?
Нет, пусть будет. Да, так лучше будет. Александр, прошу прощения, вас все еще не слышно.
I'm sorry. Dear colleagues, I have started without microphone turned on. So let me show my presentation in English, but I believe that my answers for your questions will be in Ukrainian. Computational modeling of stochastic processes for learning research. Mathematical statistics makes any science, phenomenological science, to be a real science because it gives us possibility to use mathematical methods to processing our data. Many years ago, these methods came to psychology, to pedagogy, and other sciences, and give us possibility to show, to prove that some effects is the result of our new innovation, of our innovations, but not a result of some random processes. How can we do it? First of all, we should try to see. Try to model, try to simulate simulate our process being investigated, and try to see which response can we obtain from this phenomena without any influence from the experiment data. This is a very complicated simulation. So many years ago, it was suggested some methods null hypothesis statistical testing. And this method was developed for many different situations, but not for all. So each test, each statistical test that we can use in our dissertations, for example, contains some boundaries for some limits, for some limitations for its using. These limitations are complicated. These limitations are random in such cases. So we have no enough information in our textbooks for students to suggest our students some some way of using this test that we can believe to be the best way. So we have started this work in 2014. We'll try to create some methods for students' education in statistics that will use educational investigations, educational researches for understanding the limitations of statistical methods, of statistical null hypothesis testing. For such educational research, we have created some statistical model. This model allows to form two samples from one population or from different populations that have some differences in its probability distributions. The first regime was used for type 1 error investigation. This gives us possibility to see how often can we see the effect where this effect is absent. This is type 1 error. And the second regime was used for investigation the power of the test. How often we could not see the effect when this effect is present. For organizing students' learning research, we should motivate students with some leading questions. For example, is type 1 error fixed when null hypothesis significant testing? What factors affect the power of the null hypothesis significance testing? Should we collapse matrix scale data into some intervals? Which tests should we use for small samples? What can we know about the test power when implement null hypothesis significant testing in practice? Can we prove that null hypothesis is true? Classical tests was checked in these simulations. Pearson's chi-square, Fisher's angular transformation, Fisher's exact test for consistency in 2x2 tables, Mann-Whitney test. And what is about type 1 error? That should guarantee us the type 1 error in our investigation is fixed. For example, in pedagogics, it 5%. So we can see the effect where this effect is absent only in 5% cases. But what we can see with using of our criteria. Chi-square criterion and even Fisher's exact test give us not so exact level of error. And each researcher can see these pictures and can understand that using these tests in real experiments not so small error in a level of type 1 error. Even Fisher's exact test is not exact really, because it is exact only because it contains some approximations, but it contains some simplification of situation in its basics. Let's see the situation when no hypothesis tests, statistical testing is used for more categorized values. For example, Mann-Whitney test works with the data in arranged scale. Chi-square can use not 2 but 3 or 5, and we that using more categorized testing give us more stable level of type 1 error. So this should understand that using more categories, using metric scales instead of categorized, instead of instead of categorized scale is more exact and give us a less error. Let's try to use null hypothesis significance testing for two samples with different probability distributions obtained by different random generators with given different parameters. So we can see that the main problem of all tests is of all non-parametric tests that we often use for small samples, and the main problem is its power. Only Mann-Whitney test us accessible give us enough good power, and even when size of samples is 200. In this example, of course, we should understand, and our students should understand, that power of the tests depends not only on the test quality, but also on the level of differences between samples. Now we analyze the samples with very small differences between them. If we shall use samples with much differences, we can obtain more high power or even high power, but we can see. Now we can see the example for the samples with differences in 15%, right and left. This is samples of unique probability distributions. And even in such case, we can see that some tests, for example, Fisher's angular transformation, Fisher's exact test, give us a very low power of null hypothesis significance testing. And only such tests as Mann-Whitney and chi-square with 5 categories give us appropriate level of testing power. So we can suggest conclusions. Leading researches in inductive statistics have been suggested on the base of statistical modeling. These didactic materials can be useful for master and PhD students in pedagogics. Suggested methods contain new views on the use of null hypothesis significance testing. We stress that collapsing data into less number of categories decrease the efficiency of tests and does not give any advantage in accuracy of significance level providing. We suggest to change the access in Ukrainian statistical education, including PhD studies, from using null hypothesis significance testing to statistical modeling as a modern and effective method of proving the scientific hypotheses. We ground on results of our simulations suggested in this possibilities of modern information and communication technologies, a literature review, and the opinion of American Statistical Association. Thank you. Thank you for attention.
Thank you very much,
I am ready to answer the questions.
Thank you. Dear colleagues, any question? Have you any question to Alexander Gennadievich? We can ask questions in chat or turn on your microphone and ask question your voice, please.
Oh, Тоді я спробую розпочати. Dear Олександр Геннадійович, at classical we need enough large number of measures, trials to obtain satisfactory precision of the statistical analysis. What you can recommend to researchers in social science to obtain more data than usually? Which measures, which control points you can recommend to get this data more exact, valuable, etc.?
Thank you, Sergey Alexeyevich, for your question. We cannot recommend pedagogical researchers to obtain more data for their analysis because pedagogics, this is a science about humans' behavior. So we cannot do so large experiments when we are not sure in our methods. As well as it is in medicine, in psychology. These disciplines use not very productive, very powerful methods of parametric statistics because these sciences needs to analyze small samples. Thank you.
Well, one little question. How statistical tools you recommend for statistical education?
No, the classical statistical tool for null hypothesis statistical testing is SPSS. But this is commercial product and it costs very much. We can organize all statistical analyzing according to null hypothesis statistical testings with simple with simple spreadsheets. For example, Microsoft Excel, for example, Open Office, etc. It is enough, quite enough for using statistical hypothesis significance testing. But in all these cases, we cannot obtain information about the power, about the real power of these tests. So if we can see some effects, we can say, yes, we see these effects. But if we do not see effects, we cannot say that we have proved the new hypothesis. We only can say that we need in additional analyzing with larger samples, etc. The main resume of our study is to recommend to build a model according your specific experiment and using computer-based simulations for obtaining information about how often the effect can be seen without this effect really exist. Thank you.
Thank you, Alexander Gennadievich. I will try to raise both this and previous research of Professor Kolgatin on the use of modular learning management system to obtain a big number of data on any student works, what they do, when they do, or else. At the last version of Moodle, at least at 3.9, we have even a separate module to test some statistical hypotheses on the student behavior, so-called machine learning models to predict the successful attention, retraction student from the course, or else. We can to involve both new models and new useful for ordinary teacher ideas at this system. Thank you. Have we any more questions or discussion to this talk?
Well, thank you very much, Alexander Gennadievich. And I'm glad to invite for presentation Ludmila Gryzun.
Thank you.
This topic, well,
Thank you. So can you allow me to show my screen in order to demonstrate my presentation?
Alexander, can you stop please your demonstration?
Or Ludmila Eduardovna can freely start your presentation and the former talk.
No, so I have my prepared presentation and I would like to show it, to demonstrate and comment definitely. Okay, can I?
well,
Yeah, I'm trying. Sorry. Just a moment. Can you see my screen? Okay.
Yes.
So let's get started, dear friends. I'm really happy to see all of you at the conference. I'm happy to greet all the participants of ICTERI conference and exactly of our workshop on computer simulation in education. So the topic of my presentation today is a Petri Net-based simulation of synchronized curriculum for IT specialist training. So my name is Ludmila Gryzun, and I'm happy to represent here the Information System Department of Simon Kuznets National University. And also I'm happy to introduce my co-author, full professor Lyudmila Belousova. So the outline of my presentation you can see on the screen. I'm going to cover the problems of university courses synchronization. Then I'd like to represent our author's approach to the curriculum modeling using Petri Nets facilities and to discuss some benefits of the offered approach. So talking about the problems of university courses synchronization, I'd like to say that they are caused by a number of factors, which demands the search of new approaches to the curriculum building. As for these factors, we have to recall some of them. First of all, there is quick changes and renewing of technologies, social life situation, employment market, etc. The next main factor is international students and employees' mobility, which causes international context of high contemporary education. Growth of information amount, knowledge expansion, renewing of knowledge, losing the urgency very quickly, also causes the necessity of renewing approaches to the curriculum design. And definitely the trends in contemporary scientific branches. For them, it's clear that there are synthesis of knowledge, mutual enrichment, interdisciplinary research with interpenetration of knowledge and cognitive methods, tools, etc. So all of these tendencies must be reflected in the content of training of university students, as global science and employment market demand specialists who are ready to solve integral problems, not specific and narrow ones, but really integral problems. They must have flexible system of knowledge. They must be able to use knowledge in related branches and be ready to adapt quickly to changes and to retrain, to reorient their qualification and so on. So in terms of exactly curriculum design for students in IT sphere, it's necessary to emphasize that in terms of globalization processes and permanent changing in computing, building of worldwide curricula is getting really urgent. Because its development has expanded the scope of the traditional computing disciplines, and it raises the task of preserving the natural links between the disciplines and integrating of the newly appeared disciplines into the existing curriculum. In this context, it's very important to mind the double function of any curriculum discipline. The matter is that on the one hand, the curriculum discipline is an implementation of certain educational content, and a relevant modular structure of a subject can facilitate the processes of formation of holistic and flexible system of students' knowledge and skills. On the other hand, a curriculum discipline is an embodiment of some scientific branch adapted to teaching and learning. So it must reflect correctly the branch structure, preserving main links between notions, concepts, facts, and so on. As for the challenges of IT specialist training, it's important to say about the pillars as the guidelines for curriculum building in university education. Such a curriculum has to preserve the concept of computing throughout the world and in time, as well as to support existing, emerging, and future computing disciplines, both for the today and potential students. It also has to mind future trends and achievements from industry, research, and entire spectrum of society. And it must be flexible to get global enduring acceptance and be adaptable with multiple educational contexts. So for IT specialist training, there are even more challenges as for discipline structuring and building university curriculum. So the main problems to be solved in this area are how to form integrative content of learning, how to provide modular structure of curriculum disciplines with preserving links between knowledge, and how to provide their synchronization, synchronized learning throughout the modules of different curriculum disciplines for pre-service specialist training and especially for IT specialists. It's clear that we need some alternative approaches, and it's necessary to develop approaches to curriculum design based on mathematical and digital tools, which are able to, first of all, overcome the exposed problems, to cultivate cross-disciplinary strategies of teaching and learning, and to form students' holistic, coherent, and flexible system of knowledge. So if to characterize our integrative approach to curriculum design, it's necessary to cover maybe 3 key characteristics. First of all, our approach is based on the revealed mechanisms of knowledge integration in scientific branches and in curriculum disciplines. Our approach provides technique of discipline structure which triggers the integration mechanisms realization, and it results in the coordinated system of curriculum disciplines, preserving links between knowledge and making positive impact on the trainee's system of knowledge. To cover our approach in a few words, I'd like to say that the technique of discipline structures, which was elaborated by us, is based on the ideas of multi-level construction of the content of learning, multi-level knowledge generalization, and we also put into the base of our approach applying of models of knowledge representation of artificial intelligence theory. In particular, we use semantic networks and frame-based systems with their hierarchy and inheritance properties. The process of structuring and technique of structuring covers 4 main stages. There is so-called super discipline level of discipline structure, and the level of curriculum discipline, the level of learning material, and finally the level of learning activity. To cover these stages in brief, I'd like to say that on the first level, on the super discipline level, the super discipline content is concentrated as a network of key points defined based on the analysis of the system of professional functions, the structure of the activities, standards, and so on. So they include all of these key points, which you can see on the screen. They include real objects, processes, phenomena, which are to be mastered by pre-service specialists. On the second stage, the so-called structure level of knowledge generalization. It provides general structure of the subject area and rules of knowledge manipulation. In order to realize this level, we elaborated special technique of preliminary analysis of the subject area and revealing didactic characteristic of academic disciplines. After such a comprehensive analysis, we could select so-called node key point learning elements of the subject domain around which we should concentrate learning material at modular structure. And also we match these selected learning elements around the proper key points of the super discipline level. Actually, these selected learning elements then are put into the basis of frames structure. At the next stage, there is a level of curriculum discipline, and hierarchy structure with frames in its nodes is built here. Each frame corresponds to cycles of training, to curriculum subjects, and to their modules with learning elements in their slots. At the next stage, each of the frame prototype of general structure is filled in with exact data and exact values of learning elements, and all of the inheritance pointers for each slot are established to provide proper links between learning elements. And finally, omitting some technical details, we obtain the coordinated and coherent system of curriculum subjects which are connected via learning elements. Our technique to the discipline structure and coherent curriculum shaping was implemented and even verified. We built special expertise in order to test it as for the some special criteria. However, in the process of this expertise and in the process of real curriculum building, it became clear that it is necessary to elaborate the issue of the grouping learning elements into the frames, which are in fact the modules of disciplines, because the problem of synchronization is of learning elements, of mastering by students learning elements, is really sharp, and it is essential to group learning elements, taking into account also not only the links, but also the sequence and precedence of their learning within the modules and disciplines. And it will make their mastering not only holistic, but also synchronized, which is really important in all of the directions, both in vertical and horizontal directions. So in this context, it is relevant to use the simulation advantages of Petri Nets operators in order to provide synchronization. As this well-known mechanism for the process synchronization in general and for modeling parallel processes. To cover in brief the theoretical issues of Petri Nets theory, we can say that Petri Net can be defined as a two-part oriented graph, where usually places which are circles, they usually simulate states and conditions, and transitions which are bars usually simulate events. The places or circles can accommodate so-called tokens that can move around the net, and tokens moving can simulate the process in progress. As I said above, in our approach, the disciplines are composed by the frames uniting the learning elements, and any frame has its inputs and outputs. Inputs are the learning elements necessary for the students to master in order to be able to learn the learning elements of the frame. In similar way, the outputs of each frame can be interpreted regarding to other frames. We needed to establish the different types of precedence relations for the inputs and outputs of the frames, and they were established by us. For inputs, we distinguished one learning element to one learning element relation, one of key learning elements of frame N to one learning element of different frame M relation, and the whole set of k learning elements to 1. And for outputs, they were established also two types of relations, which you can see on the screen. Using these precedence relations between learning elements, we could build a common Petri Net model for learning elements mastering. Petri Net, which simulates a learning element mastering by the students, is represented by 4 places and 8 transitions, which you can see on the screen. The places represent the states of learning elements as for their readiness to be learned by students due to their relations precedence, which we distinguished above. There is also one and only one token in the net, which means that only one of these places can be marked at a time. The transitions simulate the events of start of learning elements mastering the process of its learning regarding the academic time and its availability due to its precedence relation, and the finishing of their learning. Then net addition is done by merging transitions. T1 which simulates learning element able to start of the dependent model, and T8 which simulates a learning element ready to continue of previous model. There are 3 situations how to add the learning elements to create a frame. You can see here 3 situations is for one-to-one precedence, n-to-1 precedence, so-called AND operation, and one of n-to-1 precedence. Using the operations of Petri Nets modifications, in particular their fusion and learning elements connections of different types depicted above, we could obtain a model of a curriculum discipline module and finally a curriculum discipline model in a whole. It is essential to note that output transitions of each learning elements model can trick the subsequent learning elements model only if the previous, in terms of precedence relations, is accomplished. It is guaranteed by the rules of Petri net execution and modifications. Talking as for the results of such simulation, we could say that the built Petri nets represent all the evolution of the learning elements mastering by students in the frames, which are in fact course modules, and between them. Also, Petri Nets provides grouping learning elements into the frames, taking into account precedence of their learning, which actually provides synchronization. And at the same time, frame facilities provide spreading the set links between the learning elements within the module and between the modules of different courses. So such a modeling of shaping the frames modules provides synchronization of learning elements mastering and at the same time spreading links between them. So potential benefits, which we can predict maybe theoretically now, we can realize mechanisms of knowledge penetration in curricular subjects, and at the same time we can optimize sequence and coherence of learning, mind the discipline's evolution and the pairing new disciplines with the including into the flexible curriculum, excluding unnecessary repetition and academic time saving. The obtained curriculum with our simulation is flexible to account both global acceptance and national educational context. Second benefit to the offered approach to the course modeling, we could see in the lines of the using such a curriculum modeling in the software for automatic creation of a holistic and synchronized curriculum, which makes actually prospects of our research. This theoretical simulation will be put into the basis of automatization and building special software. Such a software will allow to detect which proper learning element and where has to be mastered, to trace the learning elements which have been mastered and will be necessary for mastering other set of learning elements, to build individual study plan for students, individual study paths, and so on. As for the university, from the standpoint of university teachers, I would say that such an approach allows to see and realize the place of each learning element in the system of learning elements of this discipline, and it links with other disciplines via mutual penetration. And in such a way, it gives university teacher understanding how to select proper methods and what kind of proper methods and techniques of learning to select on the level of learning disciplines mastering, to offer students interdisciplinary problems to solve, to provide special ways of students' activity in order to form their holistic and flexible systems of knowledge and skills, and to save academic time, and at the same time to learn each learning element comprehensively, deeply, and from the standpoint of the aspects of various disciplines. As for this one, for today, that's all. I have finished and I'm ready to answer your questions.
Thank you, Lyudmila Gardina.
Thank you.
Please. I'm sorry. at least two questions. Our National Agency on Quality Assurance is provide us some so-called standards, which in fact are use the outcome-based approach. We have some general skill or competence which need to design some parts of special professional, general professional competence, and then we need to build an ideal curriculum. At the beginning of your talk, you use another approach, the constructive design curricula, using ACM, EIE, Australian, and other standards. We have some blocks which need to be synchronized. If I right to understand that your approach can be used to both curriculum development on outcome-based approach, our national at present moment, and to synchronize the blocks during construction from some standards.
Thank you for your question. Yeah, I'm not sure that I understood your question perfectly well, but I'd like to say that partially you are right, that I can't say that my approach completely alternative one, but the core idea of our approach is to analyzing the standards, analyzing the sphere of and system of professional activity of potential pre-service specialists and his maybe potential expertise, competencies, and so on, to find out these core elements of super level of curriculum design in order to group around these main competencies, learning material, learning, and find out learning elements of each subject domain, which could cover the mastering of these key point elements of the standard, let's say it is, let's call it in such a way. And we put into the basis the approach of knowledge in the sense of artificial intelligence, where knowledge is, how to say it, there is the concentrated portion of material along with even skills, which has links with other elements of knowledge. So our learning elements, these are concentrated portions of learning material. And that is the key moment. But while doing this structuring based on frames and semantic networks, we realized that we lose synchronization. Some portions of these materials are learned earlier, some of them are learned later, and these connections which we built, actually, they are ruined a bit, in this sense, because it is not, they are dissynchronized. So in order to add the element of synchronization, we tried to use Petri Nets Modeling, simulating, using their built-in facilities in order to to provide such a synchronization. I realized. Right.
We got a real system of frame, a real framework instead of set of frames which we have in current curriculum design. Thank you. And the next questions You answer these questions in your conclusion. I'm sorry, I have no questions.
Okay.
Thank you.
Okay. Thank you for your questions and thank you for the interest. And because we are doing the have been working upon this approach for a long time, and we maybe improved it, and now we are trying to improve and to work upon this problem of synchronization. And I hope to have not only theoretical, now it's on the level of theoretical idea, but we are going to implement it, and maybe also to provide our second empirical research in order to understand how it's really impact on the knowledge characteristics of our potential trainees, our pre-service IT specialists, because it's intuitively clear that such an approach can influence and have an impact on such characteristics of knowledge like flexibility, depth of knowledge, operation of knowledge, and it's possible to also to cover efficiently the cognitive needs of students. That is why I think that it's relevant to provide the kind of empirical research in order to test how such an approach of material structuring influence on the students characteristics and the results of their educational activity. So that is the prospect of our research. Thank you. Any other questions?
Can you ask
Sure.
question? You use term learning elements. Do you investigate the term learning object, and what difference with learning elements, learning object?
I have to say that learning elements is a rather common term. It includes the understanding of the portion of knowledge. And learning object is a bit different thing. Sometimes they how to say it, cover each other, sometimes not. And we used the term learning elements exactly in the sense of portion of learning material, because as I mentioned, maybe you heard in my presentation, I said that we elaborated on some of the stages. We implemented special procedure of subject domain analysis of subject domain. And during this analysis, for this analysis, we also use special procedure. There is a topic for a separate talk, maybe. And I even published some research there are some articles where we covered this procedure of comprehensive analysis. And during this analysis, we just try to reveal these concentrated portions of material with their links, which we call learning elements. Actually, to do these things, we use special software which allows, for example, text analyst and some other software which allows to build automatically semantic network using the ideas of analysis of text. And we obtained such a semantic network of subject area. And for each discipline, we provided such an analysis with building a special semantic network. Thank you.
Thank you very much. The question in the chat, we're waiting for. Oh, it's no question.
It's a statement. It's not a question. It's a statement.
Да.
Это не вопрос, а утверждение, скорее.
Да. Yeah. Thank you very much, Людмила.
Thank you.
And
Thank you for your attention.
Yeah. And I invite the next presentation, Alexander Kostikov. I see Alexander Kostikov online, please. We don't hear you. Oh.
Do you see my presentation?
Yes, we see the third slide.
We see first slide. Yes?
Yes.
The topic of our presentation is the algorithm for knowledge assessment based on the Rush model. Currently, the task of automating process of assessment student knowledge is urgent. The relevance of the automation of the education process is determined by the need to reduce the cost of training, increase the number of students, improve the quality of education through the use of modern information technology. Currently, the problem of creating unified education environment are a priority for many higher and secondary education institutions. On the most laborious stage of education process is the control at the achieved level of knowledge. Automated testing systems solve the problem of reducing time and labor cost. But there are some problems we significantly reduce the expected effects. These problems are limitation of the formal mathematical apparatus used, the lack of an individual approach to the student, and taking into account their personal characteristics. The method of adaptive testing allows us to take into account the individual characteristics of a student to build a flexible procedure for assessing knowledge as close as possible to oral questioning, devoid of a subjective factor, to solve the problem of maximum information content of test result. Thus, the problem of development and implementing a system for effective assessing students' knowledge is relevant and requires a solution. Now, motivation of our investigation. Currently, the implementation of distance learning in higher in educational process given need use automated testing system. The development on using learning management system, especially relevant during the COVID-19 pandemic, make it urgent the implementation of automatic testing system. Also, there is the need to reduce training cost. Using of modern information technology also calls the need of using automation testing system. Now, in education, the competency approach is used. The competency are dynamic. They change it, and to estimate the competence which student obtain, it is necessary to use the system of automated testing. The statistical theory for educational assessment has two traditions. First tradition on classic test theory and the tradition of item response theory. In our investigation, we used item response theory. The root of the classical test theory go as far back as Pearson, Gulliken, standard work theory of mental test can be seen as the first comprehensive axiomatic statement of classical test theory. An important extension allowing for further elaboration of the source of unreliability in test score has become known as generalizability theory, which were developed in work of Kronbacher, Glaser. The first formulation of ART were published during and after Second World War. This is work of Lord Lovely, but the most influential contributions were made sometime later by Rush in 1960, Bilbao, Bock, and Lord. Adaptive algorithm of assessment of examiner knowledge has been considered in work Weiss, Ali, and other researchers. The task of our work, the following: automation of process of assessment student knowledge, estimation of test items quality. For solving this test, the adaptive algorithm was proposed. This algorithm can help to solve this problem. For our adaptive algorithm, we use item label theory. What rationally of the choice of the one parameter Rush model? The one parameter Rush model is a model of item response theory. There are some model This model is easy model. Значит, why we use one parameter Rush model? First reason, ease of use. Two reason, lack of assumption for parameter estimation. Three, minimal data for task for 10 students. Four, data for state abstinence, 20 tasks for 200 students. There are other models, two-parametric model Birbaum and three-parametric model, and using this model for using this model, it is necessary to have more tasks and more students for obtaining evaluable characteristics. The leading idea of item response series allows the ability to effectively predict the test result for tasks of various difficulty level. This forecast is especially necessary in systems of adaptive learning and adaptive test control. The forecast is based on the following statement. First, there are latent personality parameters inaccessible for direct observation. This parameter are the student ability and difficulty level of test task. Two, there are indicator variables related with latency parameter available for direct observation. According to the values of indicator variables, we can judge on the values of latent parameters. Three, the estimated latent parameter should be one-dimensional. This means that, for example, a test should measure knowledge in only one clearly defined subject area. ICTERI item response series convert measurement made on dichotomous or ordinate scales into linear measurements, resulting in quantitative data analyzed using quantitative method. This is advantage. This is advantage of item response series theory in comparison to classical test theory. In item response theory, the measure of parameter of Rush model is linear, which make it is possible to use a wide range of statistical procedures to analyze the measurable result. And the assessment of the difficulty of test item does not depend on the same of subject of the examiner on which it was defined. In classical theory, we obtained the different result if we use test task on weak student or student with big experience. In IRT model, in IRT theory, the result don't depend from these factors. Assessment of the test subject readiness level does not depend on the set of test items used. In classical testing theory, it is necessary the result depend from test item used in test. If we choose easy task test, we obtain best result than if we used more difficult test task. One parameter we use for building our adaptive algorithm, one parameter Rush model. On the slide, we give the formula of this model. In this formula, P sub G of theta is the probability that participant with ability theta currently performs the task with difficulty beta sub I. This probability defined from difference between theta and beta. This is logistic curve. On the slide, we have the graph. We see if the student's ability is high, the probability that this student gives the correct answer on the question tends to unity. And if the ability student, the different ability student is low, then the probability of right answering is 10 to 0. When student's ability is equal to the difficulty of task, we have the probability which is equal to 1/2. The choice of model define item information function. Item information function is defined as multiplication of probability to answer on the question and probability to give wrong answer on the question. Q of theta is equal 1 minus P of theta. We see the information function has maximum at 0 and tends to 0 when level of training tends to infinity. Characteristic of test are information function of the test and measurement error. The formula of determining this characteristic we give on the slide. We propose the adaptive testing algorithm for assessing of student knowledge. Adaptive algorithm, this is algorithm in this answer of student. The choice of the next question depend of student answer on the previous item task. If the student gives the right question, right answer, the difficulty is increased. In another, the difficulty is slower. This algorithm has the following steps. First, selection of 5 tasks for average difficulty from the bank of question. 2, finding the initial level of students' ability and the initial difficulty level of items. Reduction of obtaining initial value and beta to a sync interval scale. Calculation the information function of test. Finding the measurement error. If the measurement error is less than threshold, the adaptive testing is completed. If not, then the next task is selected from the condition module, the difference theta sub e and beta sub g minimum. Then algorithm repeated from step 3. Here we give the calculation formula from which we obtain this characteristic. We use this algorithm for assessing on student knowledge on discipline higher mathematics. We give $50 participants and 20 questions. For initial assessment of difficulty level and student abilities, difficulty level of test task and students' ability, we use learning management system Moodle. For first, we use system Moodle for initial assessment of this parameter, and further we use item response theory. Here we give the result of our investigation. We have that our test contained the easy task. Here I give not all question, the easy task, which it is necessary to eliminate from the test, because this easy task don't provide any information for assessing student knowledge. And the next step, we obtain the student ability level. Ability is closer to 0, means that student has the means capability. Next, the result of testing is characterized by information function of tested test item. On this graph, we have the information function of test and information function of each test item. Information function of test is the sum of information function of this item. From this graph, we see that in interval -4, -2, there are a lot of curve. This means that in our test there are a lot of easy questions which are non-informative, and this question it is necessary to eliminate from the test. And the next graph, this is measurement error graph. On this graph, we see the measurement error. If this error, we see that the correct estimate the student ability of student, is this ability level is between -2 to +2. Conclusions. An algorithm of adaptive knowledge assessment based on item response theory approach was proposed. This algorithm consists of initial assessment of the difficulty level of test items and students' abilities, scaling of this parameter, selection of the next question based on minimizing the model estimation of the measurement error of the knowledge level by the information function of the proposed question. And second, the test parameters were evaluated on the basis IRT theory, which identified non-informative test questions that should be excluded from the set of test items. Thank you for attention.
Thank you very much. Well, dear colleagues, have you any questions? Вопросы, пожалуйста, на любом языке. Желающие могут задать. Well, my question, Alexander, the using of Rush model is quite common approach. What's novel in your investigation? Можна будь-якою мовою зручною вам відповісти, яка новизна в вашому дослідженні, тому що використання в адаптивному тестуванні моделі Rush досить розповсюджене.
Yes, model Russia is very spread. Russian model is very spread in the world and used for adaptive tests. Our novelty, first of all, initial assessment of students' ability, and difficulty the task. 2, formula for obtaining scalar variables in a lot of sources. There are the different formula for this. And the next for our investigation, we we use this model for our practice, for estimation of student knowledge in our course. And we use a Moodle system and the item response theory. And union of this approach gives the effect.
Well, thank you. Another question, please. Okay. We haven't more questions. Thank you very much, Alexander, for your presentation. And I invite to next presentation Evgeny Shapovalov.
Hello, dear colleagues. I will present my screen. Okay. Our topic is ontology-based learning environment model of scientific studies. And actually, we are solving the problem of high amount of generated knowledge, especially in the field of the science where it's generated and analyzed. Here is a graph of growing of amount of papers devoted to biogas. It's actually my field. I'm PhD in biotechnology. And we can see that amount is growing and very slightly. And it means that we should do something with it. It's made harder to provide science, to analyze it, and to create new knowledge, because what you do may be done by someone else. And actually today we have a few approaches that systemizes knowledge. For example, it's a scientometric basis, which gives some information on the researchers and provide searching. And also it's reference managers that can systemize your own libraries. But they work only with single study, and studies between each others couldn't be compared. And actually we solve the problem, and our aim was to simplify process of analyzing. And here is some screens of PhD, and here is the result of analyzing. Here is the references, citations. And actually the problem of manually approach is that we do it very hard, and we can forget some information because we are humans. And automatical approaches to make analysis can solve both this problem. And actually our approach is educational environment, because students of Junior Academy of Science may use such ontology environment in their education when they create their scientific educational studies. And we propose to use polyhedron tool. It provides structurization, it provides ranking of data and audit of data, which may be useful. Why the structurization is very important is all studies have similar structure, and we will talk about it a little bit later. Last year we provided the research, and we structurized in form of ontology to separate studies. And this year we want to merge them and provide some management of data. To do this, we use the similar structure of each work. This is general accepted IMRAT approach. So each study consists of introduction, material and methods, results, and discussion. And as we can see from figure in the right side, level 3 is IMRAD. Introduction, methods, results, and discussion. We propose to use levels. For example, this is very generalized graph that contains data from different fields. And the level 1, it's generated generalized node, which called scientific report. Level 2 is the different fields. For example, it's biotechnology, it's maybe chemistry, biology, act. And level 3, it's actually IMRAD. Level 4, it's elements of IMRAD. I mean, for example, methods may be devoted into spectrometry, titrymetry, act. And these works are linked by level 3 and level 4. And the last level of ontology is level 5. It's nodes that represents reports exactly. Let's take a look at maths component. So each report contains introduction, methods, report, and discussion. Introduction is basic metadata and literature review. Basic metadata is cortege of hypotheses, objects, subjects, and different elements. So each report is cortege of introduction, method, and the reports and discussion, results and discussion, and second will have similar structure. And we can merge them. Sorry, there's a missed slide, but generalized ontology will contain both introduction, methods, results, and discussion of first report and in second, and it will be merged. And so how we can use it? For example, report 1 have array of methods, method A, method B, method C, and method D, and second report have array of methods, method B, method D, and method E. So method B is belong to both group of methods 1 and group of methods 2, and we can use it to link these two works. So general view of created ontology is like this. Actually, we can see that this is massive, but I will show how to use it in simplified form. And we can use such data, the metadata included into graph to provide filtering and audit. Filtering is a simple tool that can filter all set of researches and, for example, by keywords biogas, and it will show which works contains the word biogas. And the audit tool is very useful, especially for creating of educational environment. For example, if a student of Junior Academy of Science want to submit his research, the audit tool will show both the research with same or similar IM done before. And if it's was, if it will colorize it by red. And sure, all data that contains in graph may be processed by using of ranking tools of polyhedron system. For this, we input the request and input the values of our request and its importance. And as a result, we getting on the ranked list of works. This is very useful. For example, in our study on biogas, we worked on inhibition of the process, and we were very interested to find the studies in which was the highest level of ammonium that is toxic for anaerobic digestion, and the highest level of production of biogas. And that's for we can use maximum value for ammonium nitrogen in the request and the highest level of biogas production, and this system will filter, will rank these works into our request. Okay, and I will show you 2 minutes real life system. Here it is. As I told, it's hard to use, but to simplify, there's few other types of work with it. For example, it's objective ontology, and here we have similar structure, but for example, let's solve a task. I want to find set of works which contains where was used chicken menu, and here it is. Here is the works where chicken menu was used, or where was used spectrometry. In both works, it was used. And chlorella, we can see that only one work was used, chlorella vulgaris. The same is related to all IMRAD structure, for example, keywords, and we can use keywords to filter the works. Here we can see that biogas was only in one work, but methane tank was in 2 works. The second tool is audit. Here's how it looks like. For example, microjail was already in some work, but all hypotheses were fine. And here is the ranking tool. Here's choosing only parameters which are numbers, and we can choose the importance of each parameter and the way of importance. We want this parameter maximum or minimum. Here I provide some choose, and let's try to rank it. And here it is. Here's the result. We can be sure that this work will be interesting to be more familiar than second one, due to much higher rating of first work than second. Dear colleagues, this is all my presentation. If you have any questions, here's my email. You can write it. Maybe you have any questions now?
Thank you very much, dear colleagues. Your question, please. A question to presenter. Well, Evgeny, do you comparate your approach, your tools when you use with another tools, another approach for analysis, scientific studies?
Yes, in our researches, studies, this and previous, it was compared with both ontology and non-ontology tools. For example, with psychometric approach, with using just search tools, and ontology-based, for example, Multi and Excel. And you can read the detailed analysis in our work. But the main message is that the previous approaches do not provide multiple analysis studies.
Well, and a question from Sergei Semyakov and me. Why polyhedron? And polyhedron closed source system? Is Polyhedron a closed source system?
It's open to use by teachers and students, but you couldn't use the code to modify it. And Polyhedron is the very developed tool to create ontology. It's simple GUI. It requires only skills of using Excel, not coding, and it has visual editor to create such ontology.
Well, thank you. Have anybody questions? More questions? Okay. Thank you very much for your presentation, Evgeny.